We talked a little bit about how we conquered the equivalence problems and realizing that semantic is the tough one, and then how we took Java semantic concepts and brought them over to JavaScript. But to be honest, there's complexities in JavaScript and uniquenesses that aren't in Java, and we definitely want to be able to bring them into the equation. We want to basically give them semantic meaningfulness and typing. And ultimately, if we're being honest about being bidirectional in both directions, we really should take those concepts as well and be able to bring them back into Java. So let's talk about how we basically did that and what those features are. So there's really turns out to be three areas, interestingly enough, that after we brought over all of the Java constructs, all of the syntactical stuff, all the structural, all the semantics, there were three main areas that were basically missing for us to pretty much work with. One of them was basically type references. And you can think of this from C or C++, where you can have a pointer to something. Java doesn't have that. You got your classes, you got your types, you don't get pointers to them, they're concrete objects in your environment. So type references was something that was unique to JavaScript. Function references, again, not unique to C or C++ guys that are used to it, but a Java guy saying you got a pointer to his method or something is just going to look at you and say, what are you talking about? But that's true in JavaScript. You basically have that there. You have closures, which we do have closures in Java, but there's some unique problems that you have to solve in JavaScript. And then ultimately, at the end of the day, object literals. Okay, a lightweight way for you to define a type, pretty much in JavaScript, is using an object literal. And these object literals are really nothing more than name-value pairs. So if we try to bring our typing mentality to these four constructs, we should also talk about how we brought them over into Java. So what we did for the type references and the function references is that we borrowed a declaration syntax that C++ used to use to describe something as being a member of the instance or a member of the type. And we used that declaration syntax to deal with the function references and the type references. So that one wasn't too bad. We borrowed a little bit from language history in our declarations to do that. The object literal one was a problem. The object literal one's difficult in the sense because it's really a free-form type. It's simple name-value pairs. It doesn't participate in any kind of namespace. And because it's free-form, there's no controls over what's in it. So we thought about it for a while and said, well, is it really going to be nothing more than typed like a map with just name-value pairs? And we're like, that doesn't really cut it. And then we thought about it. We said, well, why don't we treat it like a type? Why don't we declare it as a real type? And with each of the members being a field or being a function, declare it exactly like a type. The problem then is if it looks exactly like a type, why isn't it a type? Well, it's not a type because it's done in a literal syntax. You can do it on the fly. You can create one and pass it around. You can't really do that with Java, but JavaScript does it all the time. So we said, okay, we have to give it a namespace. We have to give it a top-level entry, something that you can put your hands onto when you refer to it, and then describe it using our existing type information. And when you put the type space reference together with the object literal definitions looking like a class, at the end of the day, it turns out that you can actually model it reasonably well. Now, what we did do is we didn't extend to the concepts of the object literal, like things like inheritance and implementing interfaces and so forth. We didn't do those. Those are reserved for classes and more concrete types at the end of the day, but we didn't do that for object literals. And so if we look at that set, if we take that kind of programming and we want to move it over to the other side of the fence, you run into some interesting issues, right? First of all, it's like, okay, how do I get a pointer to a type? How do I get a pointer to a method? How do I model an arbitrary name-value pair? The first two about getting the type references and the function references are completely unnatural to the Java guy. But if you think about reflection, and in reflection, you can basically get a reference to a type. You can create the type on the fly. You can get a reference to a field. You can get a reference to a method. And through those references, you can reflect and then basically invoke and basically call them. So we thought about a little bit and looked at reflection and said, hey, are there any concepts that we can borrow from there? And we thought, yeah, we could, but we didn't want to introduce a whole runtime typing construct to JavaScript at this point. We said, you know what, let's stay very close to what we're trying to model, which is really just a reference to a type a reference to a method. So that's what we did. We came up with basically wrapper types. They're references that let you refer to a class, let you refer to a method, and then you can use those to pass around. We keep a Java wrapper for it. It preserves the type of what's underneath it, and can be used in doing things like callbacks, or you can invoke a new on it. So there's a little bit of work there with the wrappering. It's not as clean as you might want to be syntactically pure. It's not, but it's semantically the same. It's relatively close, and after using it for a little while and reading it, you fall in love with it relatively quickly. And it's kind of strange, actually, to a while to start programming function-oriented in Java, and then you start looking at it going, wait a minute, what did I just start doing? So people actually get confused enough where it became natural quickly. So we feel relatively okay with that. The object little one was really more about just doing almost like a map with name-value pairs at the end of the day. And those name-value pairs have the same thing. It can be field style or can be method style. So it's composition oriented. The object little ones read pretty much the same. So as far as closures went, closures got a little bit interesting with the JavaScript to Java, basically because the notion of a closure in JavaScript is slightly different than a notion of closure in Java. And the key thing in JavaScript is who's this? And this being the keyword this. So when you get a reference to a function and you go put it somewhere else, this can change. It could be the window context. You attach it to another object, and all of a sudden that object's its context. So we needed to invent something that was really the equivalent of who this is, a keyword, but we didn't want to use this. It's already taken over by Java. So basically we came up with, again, following similar what we did with the type reference and function reference, was to come up with a reference of this reference. And anywhere we saw that this reference, it could get attached to a context, whether it was a window context, whether it was a class context, whether it was an instance context, and that let you get the functional programming model complete. So we've been able to take unique JavaScript capabilities and uniquenesses in its language and still apply our semantic typing to it, and then we've been able to take those constructs and make them available to you over as a Java programmer. Now, if you have broke down all the barriers between Java and JavaScript in terms of the major equivalences and some of the unique features, this really opens the door to something very interesting, which is taking the next step, which is talking about translatability. How do you translate between the two? And then ultimately tooling. How do you do tooling between these two environments? And that's some of the next stuff we're going to talk about.